Thank you very much. So, hello, everybody, again. I'm really glad to see so many faces. I didn't expect that, to have so many people to talk about the fibers. So what I'm going to do to talk about is I'm going to share some things that I learned when I was reading about the fibers, what they are, what they are not, and what they can. Before jumping on the topic, let me introduce quickly myself. So I'm Tomasz. I'm the guy from this picture. And around 14 years ago, I started my professional career as a software developer. Before, I was doing a bit of freelancing, but I didn't even know that it's called freelancing that time. So I was doing some front-end development, back-end development, full-stack development too. Right now, I do what I really like. So I do lead the teams. I help people to achieve their goals. I do that at the road surfer. We are here at the IPC, so if you left this room and to the right, there is some fancy bully stand, so you can step by and have a chat with us. That's all about me. As a fun fact, that's my very first conference talk, so I'm a little bit nervous. Hopefully it's going well. It will go well till the end. So jumping on the fibers itself, we are not today here to talk about the best fibers for the PHP developers, but they are very important, so please feel free to step by and take a banana or an apple after the call, after the talk. Yeah, so what are the fibers and what they are not? That's our topic today. Is there anybody who is using the fibers currently in the room? Is there anybody who maybe uses the fibers but doesn't know that he's using them? All right. So probably it's a correct answer because why? I will answer it later. But if you would like to know what the fibers are, if you go to the PHP RFC, you will see that the fibers allow the creation of full-stack interruptible functions that can be used to implement cooperative multitasking in PHP. They are also known as coroutines or green threads. That's kind of complicated. I remember me reading that sentence, and I was like, OK, that's probably enough for today. What they are, it's way simpler than this sentence. Fibers, it's a concept. It's a simple mechanism that allows us to run code, to suspend it, to resume it anytime, and we do it from our code. And fibers meant to help us with multitasking. And that's why I was asking if somebody does not know if they are using it, because they are not intended for the end user usage. Simply about, in the short words about the fibers itself, it's the fiber class is available for us since PHP 8.1. That was released, I think, November or October last year, at least at the end of the year. And how does it look? So we have a couple of available methods. We have a construct method, which is expecting a callable function that's going to be called when we start a fiber, and that's another method that we have. We have a suspend method, which is, well, suspending the execution of the fiber. And if we have something that suspends our fiber, we have as well a method for resuming it. We have a couple of is methods: is started, is suspended, is running, is terminated. That are methods that are allowing us to check the current state of the fiber. This get, return, and throw, those methods are helping us to check the currently executing fiber instance, to get the value from the fiber as well, and to throw the exception. So we know how the fiber is structured. We know what kind of methods they have, what kind of mechanism it is. It allows us to run a code. But how about the execution flow? How does it really work? We can see it here. So if we look on the normal code execution in the PHP, it's a sequential execution. So we have some code block that is getting executed. I think it's like a purple color. So let's say it's some main program that has some methods, and it goes from the top to the bottom of our file to execute. And we have a fiber way of doing things. That means we run our code, we run on main program, and then at some point we start a fiber. It jumps out of the main execution flow, executes the fiber unless it's suspended or terminated, and then comes back to the main execution. So one important thing is that the fiber pauses the entire execution stack. And that may sound a little bit complicated or too abstract, so you can imagine right now that you would like to drive to Munich from Berlin. And you like your car, so you want to go with your car to Munich. But at the same time, you like cycling, so you would like to cycle too. So imagine like driving your car, and at some point saying like, oh, no, now I'm going to cycle. You cycle a bit, and then you are coming back to your car and driving further. So this is how the jump between the main execution stack and the fiber works. So that gives us a way of doing concurrent execution of the code. And how the fiber example looks like, probably the simplest one that I could find in the PHP documentation. This is how it looks. So as we were talking before, the fiber is expecting some callable functioning method construct. So we can see here in the body of it, we start the fiber, and in the body we have a suspend method called with some value of fiber. The second line of the body of the function is saying is echoing us a value used to resume fiber is some value. So what's happening here is nothing unless we call the start method. So when we start the when we call the start method, we are going into that function, and what will happen? It immediately will call the suspend method. So our output will be value from the fiber suspending. It's a fiber, so we are ending up here. So we got the value from the start method. The start method is returning us some value that was that was passed to the suspend method. That's why we are able to display it here. And the next line, what we are doing, we are resuming the fiber that was suspended before. And the output of that execution will be a test. So the value used to resume the fiber, it was test. So we went back to our fiber, we ended up here, and we got our output. What was happening behind the scenes when we suspend the fiber and we resume it? Unfortunately, I'm not a C developer, so I cannot explain you like on the very low level like what is happening there. But it simply does the copy into a memory of your fiber, and when you're resuming it, it just brings it back to you, and that's why we are having that output. That could make you thinking like, or maybe you already heard about fibers that could be like asynchronous, or maybe you catch some articles that were saying that the asynchronous fibers are here. That's true, and we are right now on the way of thinking of asynchronous PHP or synchronous PHP. So what kind of execution we will have? So quick wrap up, like how different it is. It's very simple. So synchronous execution we have on the left here, and let's imagine we have three methods. It's a blue, green, and in yellow. And if we run them synchronously, they would take some amount of time because they are executed one after another. With asynchronous way of execution, we have this benefit of starting them possibly at the same time, and then we will wait for a callback saying like, hey, I'm done, this is my output. When I was starting learning about the PHP fibers themselves, I was thinking like, oh, cool, finally something that I can run like asynchronously in my PHP code, and I don't have to worry about. It's not that easy. We still need some mechanism to run them asynchronously. So you can imagine that maybe projects like PHP, React PHP, or some other projects, they will really benefit from the Fibers feature, but you still need something on top to run the Fibers asynchronously. So a quick wrap-up, what the Fibers are. So Fiber is a simple mechanism allowing us to do multitasking. They do not offer the asynchronous computing by itself, and you will still need some scheduler or some library to run it async. And of course, asynchronous will give you the better performance at the end. With all this, what we are talking today, you may think that, all right, but there is something already similar in PHP. How about threads? I never used like directly threads, to be honest, but I did take a look on the documentation, and what it says, when the start method of a thread is invoked, the run method code will be executed in separated thread in parallel. That's quite cool, right? We have already like Fibers existing with the thread name. It's not really like that. They are very different. The thread in the PHP is controlled by OS or some VM, and we cannot really have a control over that. The Fibers, from the other hand, they are handled by a runtime. And probably the biggest difference here would be that the life cycle of Fibers is controlled by developer. So we decide when the Fiber is suspending itself, when it's resumed, and when we let it to be terminated. And the last thing, which I listed here, is that the Fibers can pause the entire execution stack. So our main program will wait until the Fiber will be executed. And here it's worth to mention as well that we can have like only one Fiber running at a time. So if it's not threads, we could think like, yeah, there was something like generators in the PHP. They were like asynchronously working. And there is a lot of truth. They are quite similar. But again, they are a bit different. So Fibers versus generators, the common things that they can take some methods, arguments, they can suspend themselves, they can return some value, they can resume. However, the Fibers have no yield. You can't iterate on them, and they can be accessed anywhere. So if you pass the reference there, you can access it. So that's about the Fibers in general, about the theory, and so on. I prepared some examples. So if you would scan the QR code, you can see the Rickroll page. Just kidding. It's linking to the GitHub page. So if you want to see the examples on your screen. I see some people still scanning it. Are we all done? I see some people still scanning. All right. So let me quickly switch from the presentation to my editor. Is it too small, or it's OK? Let me fix that then. Now OK? I hope so. So the first example would be a very easy one. So we have an array of fruits. And what I would like to have, I would like to have some fiber that would iterate across all the fruits and maybe tell me like how many letters every fruit name has. And that I'm going to do in a loop because I'm expecting an array. And I will suspend after the first execution of the loop with some index number. So if I would run my code right now, that's the first example, nothing is happening because, of course, I didn't start anything. So the fiber itself, it won't start on its own. So right now, if I would say fiber start with some array of fruits, and I would run it, I would get the answer from my fiber saying that the fruit apple has 5 letters. So what was happening here? We called the start method, which was going inside the function. And what we did here, we simply said, OK, the index is 0 before iterating through the array. We take all the fruits. The first fruit has so many letters, and we suspend. I was telling you before that the suspend method is returning the value that we pass. So right now, if I would like to know what kind of loop index it was, I could call it and say loop index is 0. Because that was the value returned by the suspend method, which is over here. What I wanted to show you as well is some is methods examples. So we can check if our fiber is really running. So if I would take a look right now, I see the output. So the fruit apple has 5 letters. The loop index was 0. And is it running? No. Is it suspended? Yes. That's about these 2 basic is methods. So what would happen then if I would say resume the fiber after that? So maybe we don't need those methods here for now, but what was happening here is we started the fiber, we got some output, like here, and then we resumed the fiber, and it was resuming from the second element of the array that we passed before, because the first one was already processed, and since we were suspending the fiber and it was kept in the memory, it was waiting for us until we resume it. So what we can do more? Probably we don't want to like run every time, like a resume every time. So we possibly could run it into kind of loop to illustrate how the termination of the fiber works. So here I have the second example, which is doing pretty much the same, except I put the index here to display. So if I would start it right now, I would have like index 0 again, and the fruit apple has 5 letters. What we could do now, we could run the while loop, where we would expect to to run it as long as the fiber is not terminated. And the only thing which we will be running is fiber resume. So let's try it. What was happening here? We went through to the end of our array here, and we process all of it. At some point, it stopped processing the array because the isTerminated method returned true. That's why we didn't go further. So if we would use some helper methods right now to check how much, what kind of state of the fiber is, that would be looking like that. So is the fiber running? No. Is it suspended? No. Is it terminated? True. Why it was happening? The reason is very, very simple. The fiber was running as long as it had some data to process. In our case, it was an array of fruits. Wherever it come to the end of the array, it never went to suspend method. It just exited. It finished execution. So that means that the fiber was terminating itself because there was nothing more to do. I was checking as well. I was really curious if we can do some crazy stuff like running a fiber from a fiber and do some fiber inception, and apparently it's possible. So if you look over here, we have again the same fiber, except there is a small difference. So I created here like a second fiber that inside itself calls the start on the fiber number first, which I pass into the callable, and then I'm iterating until it's terminated. So I never start from the main program a fiber 1. It started inside the fiber 2. So if I would run it right now, it would still give us the same output, but except it was started from the fiber itself. So that was the 3 examples that I prepared for you. And here you can see I was prepared in the case if I could not share my screen with the code. I just did some screenshots, hoping that it's big enough to see, but luckily I could do the things. So that was all from my side that I prepared for today. I hope that gave you some outlook on the fibers itself. You probably won't use them like directly, but with some projects like maybe some Guzzle or something else to let us call the resources asynchronously, we will use the fibers themselves, but indirectly, simply. This QR code is linking to my LinkedIn profile, so if you want to say hi or you want to have some feedback, and you cannot catch me on the booth, feel free to scan it and take a look on my profile. You can find me on LinkedIn, as I said before, and I'm as well on this fancy booth, Road Surfer, which is straight away and a little bit to the right from this room. So we are hiring you if you want to have a look what we do. Feel free. Thank you very much. Is there any question that I could answer? I see at least 3.
Okay, yeah, I'm just waiting until the microphone is on because if someone is asking a question, our remote audience won't hear it. So I'm just waiting a quick second.
It's all right.
Okay, so perfect. So what's the first one? I guess okay, here.
Hello. Was very nice, this presentation, but I'm struggling to see where, because in this way, for example, the last example, you present one fiber that is calling the second one, and inside of that, I see the execution. So I feel it a little bit is still sync a little bit. I don't know. So my question is, for example, you put some text. It's possible to see the execution of the fiber itself and see the text arrive before or at the end of that or something like that in order to see the async?
I think I know what you mean. So if we would quickly look on this, if we could quickly look on this chart, so this execution flow. So you can imagine, like in my example, the purple one, we were jumping into the fiber, and then you would have like another fiber here. So this fiber was, so main execution stack was paused. This fiber was not running, and this one was running. And then after that, we came back to so this fiber here, which was giving us the output, was at the end terminated. Then we came back here to this one. It has as well nothing more to do. So it's getting terminated, and we are coming back to the main flow. So it's still, like you said, it's not like asynchronous. We are not running it like on the both hands at the same time. That's why I was mentioning that we still would need some scheduler, some kind of library that would allow us to, like, hey, I would like to have those two fibers running, and please come back to me when it's done. So I had the same problem with understanding it at the beginning, because it was like, hey, like I wanted to have like asynchronous things, but there was nothing like that. So what I learned was that yeah, we still need some kind of like promise from the JavaScript world, something similar. Does that answer your question?
Yes, thank you so much.
You're welcome.
Does anyone else a question? Okay.
Hello. Yeah, so I was wondering what is the use of the Isrunning method. If the main code is always blocked, this will never be able to return true, because it can only when the fiber is done, it will be able to be executed in the main code, and then it always returns false.
True. So it could be helpful if you could check your code asynchronously. So if you would have this fiber like running, then you could get the output that you would expect. Is this what you are? I'm not sure if I got the question.
Yeah, I mean, if the main code is always blocked, I can never call Isrunning while the fiber is still working.
That seems like a very valid question, which now I'm thinking about. Like maybe this is something which I should like still learn a bit about. A very good question, but I believe there is some use case for that that maybe we have to discover somehow that I cannot answer at the moment. Sorry about that.
Okay, thanks.
Does anyone else a question? Okay, just go. This.
So I want to ask that when running a sequential program as compared to the fiber one, the execution time will be the same, right?
Currently, yes. So there is this is what I was explaining to our colleague here. So right now it will be like sequential still. You won't run it in a parallel, but you will just jump to the other task that would be like isolated and separated.
So it's basically a coroutine. We are calling a coroutine, and then it will returning to the main program.
Exactly like you said. It's the same. That's why the fibers are sometimes called like coroutines or the green threads. Yeah.
Could you give us some live example or real-time example where we can use this fiber?
Yes, I think maybe I cannot code it right now, but I think I can give you the example of, for example, calling some API. imagine like right now, if you would call a file get content method in the PHP, it's like a blocking call to the methods, right? So nothing will be executed after that until it's finished, until you get like a full 100% of the file. With the fibers and some scheduler, you could possibly run the download of the file in the parallel, so it would not block your code execution.
Yeah, but not using fibers, but using an external library, then we can.
Exactly, yeah. So you still need some scheduler to do that. So some kind of like mechanism that will allow you to run the codec asynchronously.
Okay, thank you.
You're welcome.
So I've seen some hands here. Yes.
Hello.
Hi.
Have you tried to use something like a database connection in a fiber, then suspend and resume and see if it still works or it gets disconnected?
That I didn't try. It's a good case, which I think I was reading about that it could be possible to keep it, but I'm not really sure how it would behave in a long run. If we keep the connection still alive, or if it's like, because if you suspend the fiber, it goes to the memory. So if probably the connection would broke at some point because of the timeout or something like that, I believe.
Okay, has anyone else a question? Okay. Just a second, can I? Thank you very much.
Okay, so not directly, or well, maybe a question. Just to recap, if I understand correctly, so the use case would be to just switch tasks. So if you have something long running, you don't need to busy wait until it's completely done, but you can say, okay, like read that first 10% of the file and then pause, and then I can do some work where I only need like the first parts of the file, and then you can resume and read the rest of the file, which, yeah, where it doesn't matter that it needs to be done right now, right? So just switching tasks to be a bit more efficient, to do things a bit earlier than needing to wait for the full thing to finish.
Yeah, exactly. So at the end, you have this, it's like simple mechanism that gives you like, hey, take that part a bit away, and it has its own place to exist, and at some point it's terminated or it's suspended and waits for you.
Mm-hmm. Okay, thank you. Yeah.
So anyone else has a question? Okay.
Hi, thank you for presentation. Have you been unit testing it, and have you had any problems with it in practical way?
So far, I think like I didn't spend much time on trying to do a unit test. I did once on the very beginning some try for checking like how it is going to work with the unit test, and if I will resume it, how it is going to work. Didn't experience anything that I could mention here that was like blocking or making it impossible to do. I think it's possible.
Thanks.
Is anyone left here? No? Okay, so then I would just come to you. So you also have a remote audience that has some questions, and I will just read it out to you. So Mr. Silver has a question. Can anyone think of a real-world example where fibers might be useful? I think we also had that. But
I think we had that question from the colleague over there.
all right. So Peter has a question. What is the real benefit of using fibers because they are sync? Why not just use PHP classes, methods, and so on?
Yeah, I think that that's something which we were talking. We were comparing on the slides, we were comparing them to threads, why they are like a little bit more usable. And I think the colleagues over there, they were asking like about something similar. So in my eyes, simply just to have like a clear separation, just to take the code outside of the main stack and have a separated place to control it and to execute it.
All right. So Aline has another question: how to use them in async mode?
They don't have async mode by themselves.
Did I pronounce it right?
Yeah.
Okay.
So they don't have the async mode by themselves. They still need some mechanism that will give us the async. They are really primitive mechanism that has, like, as you could see, a couple of methods that are allowing to start or stop them.
Okay, there's another question from Cesar. I hope I pronounced your name right. So my understanding is the main process will always wait the fiber process. Can I run more than one fiber in parallel, like parallel so? Or P threads? I'm sorry, it always switch. P threads, so PHP extensions?
All right. No, we can run only one fiber at a time. That's the first thing. And they are blocking the main stack execution. And they are similar to threads like we were talking before, but they are different because we fully control them as a developer. So that's something from a little bit different angle.
Okay. Miguel has another question. Is there any current library or scheduler in order to make fibers async? Yeah,
I cannot tell you the name, but I was Googling that today morning. If you will Google for asynchronous fibers or asynchronous PHP, there is at least 2 or 3 of them that will allow you to have actually real examples of these HTTP asynchronous queries to some APIs or to download some files. So there is something on the GitHub. You will find it definitely easily.
All right. So I think everyone asked you the question that they had. Oh, no. There is another question. So what benefit we get taking the task in a solitary or something? Also, why are calling this concurrency if in reality we don't get that?
It's multitasking. I think we understand it as a way of doing a couple of things on the same time, but they are dependent on each other. So they are not async, like I was mentioning, but they allow us to have this separation of concerns of the things. So that's what we ideally have. So we don't have a mixed things. We have separated things that are executed in their own ecosystem, so to say.
All right. Okay, there's another question from Michael. If you need another library anyway to schedule the whole thing, what are the advantages over, for example, prompt? No, I think I did that, all right?
Yeah, it would be pretty same question.
Yeah, it's the same one. Okay. So is there any other question left here in the room? No? Okay, and I think we also answered all the questions online. So thank you very much. Thank you very much.
Thank you all.